One of the best ways to add power to any engine project is with a cam swap. But just like with a complete engine build, the new cam has to be degreed in. Otherwise, there's just too many things that can go wrong. This is a comp cam, solid flat tappet cam I'm installing in a small block Chevy for an upgrade in power. A new cam, lifters, and timing chain means that the cam needs to be degreed in, but you don't have to remove the cylinder heads to do it. Powerhouse Products sells a heads-on cam degreeing kit that includes practically everything you need to degree in a camshaft with the valve train in place. It's an easy process, practically foolproof, and here's how you do it. After you've installed your cam, go ahead and install the timing set. You may need to make adjustments later, so bolting it up all the way complete with the lock plate isn't necessary right now. Install the timing set straight up or with the timing marks pointing toward each other. This timing set from Comp Cams allows me several adjustment options, but the zero mark is plainly visible. If you really want to, you can degree your cam with the real valve springs in place, but the Powerhouse kit includes a pair of lightweight checking springs, so I definitely prefer to make the change. The lighter weight springs make the engine easier to spin over, and it also helps you hit specific points with better accuracy. If you don't have a set of push rods that are the correct length, you'll need to use an adjustable checking push rod. If that's the case, you will definitely need to use the lightweight check springs because the adjustable checking push rod can't stand up to the force of a real valve spring and it'll bend. Lots of grease on the end of the lifters can change your readings, so I use only light oil during the process. Afterward, I'll pull the lifters and lubricate them properly. If you're using hydraulic lifters, your standard valve springs will collapse the lifter, so that's another situation where the checking springs are mandatory. Next, follow up with your push rods and rocker arms. Unlike final assembly, you want to adjust the rocker here so that there's no lash. Any lash in the valve train will throw off your ability to properly read maximum valve lift. There are several ways you can attach the degree wheel, but by far the easiest is with a crank socket like this one I got from Powerhouse. The socket has a slot that fits over the crank key, and after it's installed, you can tighten the set screw and take any wiggle out for absolutely precise cam degree measurement. After it's on, a locking collar holds the degree wheel securely in position. Now, bolt the included wire pointer to the front of the engine. One of the water pump bolt holes usually work best, and bend it so that it points over the front of the degree wheel as close as possible without touching it. The included piston stop will help you find TDC, but first use a flashlight to make sure the piston is down in the bore. Piston stop threads into a spark plug hole and extends into the combustion chamber deep enough to limit the full sweep of the piston. By using the piston stop and the degree wheel, it's easy to find top dead center. First, rotate the engine slowly clockwise until the piston contacts the stop. On this engine, the piston contacted the stop at the 124 degree mark. Now carefully rotate the engine in the opposite direction until it stops again. This time we get 165. Once you have those 2 points, you can remove the piston stop to get it out of the way. Piston top dead center is the midpoint between the two stops, which can be found by averaging the numbers together. The average of 124 and 165 is 144.5, so we'll go there now. This is your top dead center mark. Once the engine is at top dead center, reorient the degree wheel so that the zero is now underneath the wire marker and lock it back down tight once again. The last step before you actually begin degreeing in the cam is to install the dial indicator on the retainer for the intake valve. The Powerhouse kit includes a stand that threads into the valve cover bolt holes and lets you easily position the dial indicator properly. Position the indicator so that it's reading off the top of the spring retainer and in a parallel line with the valve stem. This is critical so you can make sure the dial indicator reads the proper amount of valve travel all the way through its motion. Comp Cams includes a cam card with every camshaft that gives all the important specs, including the intake center line and duration at 50 thousandths of an inch of lift. These are the two figures we will use to degree in the cam. If you like, you can also check the intake and exhaust opening and closing points. Checking the duration at 50 thousandths inch lobe lift is recommended because the slow opening and closing ramps can make it difficult to tell exactly when the valve opens and closes. But since we're measuring at the valve and not directly off the cam lobe, we'll need to take into account the leverage created at the valve by the rocker ratio. We're using Comp Cam's 1.52:1 ratio rockers, so we'll multiply the 50 thousandths inch lobe lift by the rocker ratio to get the actual lift at the valve. That's 76 thousandths of an inch in this case. Rotate the engine slowly clockwise until the indicator shows 76 thousandths of an inch of lift at the valve, and look at the degree wheel. Count the degrees from either TDC or BDC, whichever is closer. Bottom dead center is marked as 180 degrees on this wheel, but while checking duration, we'll consider it 0. Since the BDC marker is closer, we'll count up from there and get 42 degrees. Continue rotating the engine through camshaft max lift and stop when the lifter is 76 thousandths of an inch away from closing. If you accidentally go too far, back up beyond your mark and try again. All your measurements should be made with the engine turning clockwise, because any slack in the timing chain can throw off your readings if you spin the engine backwards. The number we came up for valve close is 17 degrees. To find duration, add your opening number plus your closing number plus 180 degrees. So for this engine, the closing number is 17 plus 42 plus 180, and the result is 239. Checking back against the cam card, comp tells us that the rated duration at 50 thousandths inch lobe lift is 240 degrees. And that 1 degree of error is realistically inconsequential. With that done, we know the duration is correct for the intake lobe, but we're not finished quite yet. Next, we want to check the intake center line, and that's just as easy to do. To begin, find the maximum lift of the valve and then zero out your dial indicator on that point. Back up and then roll the engine clockwise until you are 50 thousandths of an inch below maximum valve lift, and read the mark on the degree wheel. For this cam, we're at 61 degrees. Now, find the location on the degree wheel at 50 thousandths of an inch after maximum valve lift. We got 145 degrees. To find the intake center line, average those two numbers. Our outcome is 103 degrees, which matches up perfectly with the cam card. And with that, we've confirmed that the intake side of the camshaft matches the manufacturer's spec. Most people will be fine here, but if you like, you can go ahead and repeat the process on the exhaust lobe. But for me at least, I'm going to go back and lock down my timing set and finish my engine build.